A lot of you were worried that we were skipping 4.2, as you should have been, because it's about the unit circle, and the unit circle is huge. The unit circle is going to be a fundamental basis in the study of our trigonometric functions. So, what you need to know when you walk away from this is how our unit circle is partitioned. There are certain hot spots along this unit circle, and how it's partitioned, you need to know them. The other thing you want to walk away with is being able to use your special right triangles on the unit circle. And then you also want to develop tricks to identify the x-y coordinates at those hot spots, the degree measurements of those hot spots, and the radian measures of those hot spots. Alright, so what exactly is the unit circle? It is defined as a circle of radius 1 situated on the xy coordinate plane with the center at 0, 0. So if you'll notice here we have the center at 0, 0. This right here would be over 1, right? Up 1, back 1, down 1. Okay, so this is our unit circle sitting on the coordinate grid. So now to look at a very detailed unit circle, here we have it. Alright, so picture this is our 0, 0. So picture an x-axis and a y-axis straight through the middle of this. That would make this point over 1, 0, right? Because we have a radius length of 1, so it's over 1, up 0. This one then is going to be 0, 1. This point over here is going to be negative 1, 0, because it's back 1. And then we're going to have, oops, I already filled that in, 0, negative 1. Okay, so now knowing that, we're eventually going to fill in these other xy values, and I'm only going to help you with the top. You're going to be responsible for figuring out the rest of this based off of what we learn on the top. Alright, so the first thing to know, of course, I'm going to fill this out. If we were in a standard form, what we would have right here is 0 degrees. An angle that opened nothing is just going to be 0 degrees, and then therefore the radians also, you walked nothing along the outside perimeter of the circle, so that's also 0 degrees. What I'm going to do is I'm going to emphasize these key lines. This one, this one, this one. So these are our key lines, and what I hope you notice is if we went halfway around the circle, trace that arc, what we do know is halfway around the circle is 180 degrees. So I am going to write that. And the radian measure, we know all the way around is 360, so halfway around is 180. All the way around in radians would be 2 pi. Halfway around would just be pi. Okay, so what I'm going to say then is if you were to look at these key points that I've marked, or these key lines that I've segmented on my unit circle, what I've done is I've taken this pi amount and I've separated it into 6 equal pieces. So this one I'm going to say would be just 1/6 pi. So pi over 6. This piece right here would be 1/6 of 180. So 1/6 of 180 you would find 6 times 180 would be 30 degrees. So there are those. And whether or not you got the 30 degrees first or the radians first, you could always do your conversion of saying, alright, well let's say I know that 1/6 of 180 was 30 degrees, and you needed to figure out what is the radian amount then that goes along with that. Well, you could set up the proportion like we worked on in 4.1. So 30 times pi divided by 180 is equal to r. Okay, right? Because this times this divided by 180 equals r. So when you reduce this down, what you are going to get is 30 goes into 180 6 times. And then 30 divided by 30 is just 1. So 1/6 pi. This one, what I would notice is then you're going to go skip to this line. So this was 130 degrees. This was 230 degrees. It's 60. Right? You could take this and do your conversion just like we did here and write this as 60 instead. But otherwise you can also mark that this was 1 pi sixth. Therefore this would be 2 pi sixth, and 2 pi sixths, when you reduce that, is just going to be 3 and then a 1. So 1 pi third, or pi thirds. This one right here is 1, 2, 3 pi sixths, but we also know that is just pi over 2. 3 over 6 would just be the same thing as 1/2 pi. And then this one we also know is 90 because it was 1, 2, 3 times 30 is 90. So I'm going to go ahead and fill these in. 120 degrees. This one was 1, 2, 3, 4 pi sixths, oops, which I'm actually going to simplify that. That would be the same thing, 4 pi sixths divide by 2 on top. That's going to be 2 pi divided by 2 on bottom, 2 pi thirds. This right here is 150. And we have 5 pi sixths. Okay. And then we have 6 pi sixths, which is pi. And then 1/8. Now I'm going to take this half of a circle and I'm going to separate it like this. What I've done with these red lines, you can see, is I've taken this pi and separated it into 4 equal sections. So I'm going to go ahead and say, well, 1/4 would just be this segment, right? Here's 2/4, here's 3/4, and then 4/4 of this whole pi area. So what I'm going to do is I'm going to say, well, 180 times 1/4, or 1/4 of 180, is going to be 45 degrees. Right? If we moved along and did two 45-degree angles, we would get our 90. Here we're going to go to 3 45, so it's going to be 135 degrees. And then for our radians, now you can either do your conversions and put 45 here, or you can go ahead and say, well, this would be 1/4 pi, so pi over 4. This thing would be 2 pi fourths, right? Because you would have walk around pi fourths radians. But then this would be 2 pi fourths, so in other words, pi halves, 3 pi fourths, and that's going to be this radian measurement right there. So now that we have our degrees and our radian measurements of these hot spots in, now what we need are the x, y values of these coordinate points. So keep in mind, if I went over 1, up 1, that would be 1, 1 up here. Okay, don't forget we're on the coordinate grid. So what is this x and this y value? Well, as we said in the last video, every point on the coordinate grid has a horizontal and a vertical movement to get to it. So I'm going to do that. I'm going to go from my origin and then go up to that hot spot on my unit circle. You can hopefully see your right triangle formed right there. So I'm going to take my special triangle, because my 30-degree reference angle is sitting right here. That makes this a 30, 60, 90 special right triangle. So I'm going to take my 30, 60, 90 and I'm going to put it over here, but I'm going to have to rotate this a little bit. Alright, and you can see it fits nicely in that spot. So that's what you're going to be doing. You're going to be using that horizontal and vertical movement to spot your right triangles, and then you can use your special right triangles to fit in there. So what we're going to find is that, don't forget, we know the lengths for this. This is a hypotenuse 1. And this is a hypotenuse 1 because it's a unit circle. The radius of these, or the hypotenuses of all of these, are 1 in length because it's the unit circle by definition. So then we therefore know the longer leg and the shorter leg. 1/2 is going to be the shorter leg of this 30, 60, 90. Here's my 60. There's my 30. And the longer leg is going to be the square root of 3 over 2. So now that I know that in order to move over and up, I move the length of the square root of 3 over 2 to do the horizontal long length, and then 1/2. I'm going to take this and move it right into this 45-degree reference angle that we had. Okay, and I know the lengths of this as well. It's 1, and then the square root of 2 over 2, square root of 2 over 2, because this is our other special right triangle. So now what we can say then is the values of the x, the over and the up, that would have taken me to get to this point is the square root of 2 over 2, square root of 2 over 2. I'm going to go ahead and take this one and fit it right into that 60-degree reference angle. So here I would have now the shorter leg as my x value, 1/2, and then the longer leg, the square root of 3 over 2, as the y value. Now I'm just going to take these and I'm going to flip them. Because if you did look over here, to get to this point, which is our next unknown point, we filled in all the way so far, I need to go back and up. And hopefully we can see that nice special triangle, and that this reference angle, if you calculated the reference angle of 120 as you practiced, then what we know is the rest of the way here is a 60. So we're going to take this special right triangle and we're going to put it, I'm just going to flip it actually. I'm going to flip it right into its spot. Horizontal flip, and there it is. Okay, so the only thing that we have to be cautious of here is we went backwards on the x, so that short 1/2 leg is going to be negative, and then the long square root of 3 over 2 is still positive. So this one is going to be negative square root of 2 over 2. This is positive square root of 2 over 2. This one right here is going to be, if you can't see it, I will flip this one. There we have it. So it's back the longer leg of this 30, 60, 90, our very special triangle, and then up 1/2. Alright, so I challenge you to finish the rest of the circle.